Hello and welcome to the Solving Quadratics video. In this video, we're going to be looking at 3 different ways to solve quadratic equations. Actually, we're really going to be looking at 2 different ways since this first way right here, solve each equation by factoring, we've already been covering that for the last few days, so I'm not going to include it in this video. Feel free to watch some of the previous videos. However, I will say, please make sure before you factor that everything is set equal to 0. Factoring does not work unless it's set equal to 0. So for instance, problem number 5 is set equal to -6. Start by adding 6 to both sides and then factor as you see fit. That's all I'm going to say on that matter. Next, we're going to be looking at taking the square roots of each equation and then finally with the quadratic formula. So I'm going to zoom in on these just a little bit so we can talk about these. If you remember the quadratic formula, there is a song to it. I don't know if your teacher taught it to you, but the quadratic formula itself is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to be solving for those x values, and we'll talk a little bit about that. As you may be able to tell, there's not really enough space to show work with these problems, so I'm just going to let you know right now, we're going to go over problems 9, 10, 13, 14, and 15. So let's get started. If we scroll down just a bit, we'll write out problem number 9. Problem number 9, whoops, there we go, is 9n squared minus 5 is equal to 715. Some of these problems have pretty big numbers. Feel free to grab a calculator. I certainly know that when working on this, I had mine next to me. But our goal now is just get n by itself. So we are going to start by adding 5 to both sides. We'll have 9n squared is equal to 720. Then we'll divide both sides by 9, and we'll get n is equal to 80. Oh, pardon me, n squared is equal to 80. And then to undo that squared, we're going to square root both sides. Now, please, please, please do not forget that when we take the square root of something when we're solving, we need that plus or minus out in front because we could have a positive answer or a negative answer. So this right here is my answer. I'm not going to worry about simplifying under the radical. If you have questions about how to do that, stay after class and we can work on that together. But I'm okay with this answer, where n is equal to the positive and negative version of square root of 80. If you would also like to say, or n is equal to square root of 80 and negative square root of 80, if you'd rather write it like this is also totally fine. So this is problem number 9. Not too bad. Problem 10 gets slightly more exciting. So I'm going to move this over just a bit. There we go. Let's see, problem number 10, 9x squared plus 4 is equal to -150. So at this point, we're just trying to get x by itself. So I'm going to start by subtracting 4 on both sides. We get 9x squared is equal to -154. Then I'm going to divide both sides by 9. This is the point where I grabbed out my calculator and I was like, you know what? 9 does not go into -154 nicely. So it's just -154 over 9. Not the best number, but that's okay. So next, to get x by itself, we're going to take the square root of both sides. So notice how big my square root or my radical symbol is on this side. It's got to cover the 9 as well. And we're going to end up with x is equal to the square root of -154 over 9. Now I look at this and I go, I thought Ms. Twain said we weren't supposed to have square roots or negatives under the square root when we were dealing with domain. She said that wasn't allowed. And you know what? You are right. I 100% did say that. So let me show you how we're going to deal with that. We're going to take this negative right here. This negative, you can think about it being multiplied by a -1. And the square root of -1 is I, or an imaginary number. Now, we're not really going to be dealing with imaginary numbers, but I just want to make sure that I made a note to you saying that if you have a negative inside the radical symbol, which is the official name for that square root symbol, it's going to become, or it becomes, an I on the outside of that square root symbol. So, as you may have guessed, for imaginary numbers, we use the symbol I for that. So instead of having a negative underneath the square root, which Ms. Twain said was not allowed, we're going to say that x is equal to, and I totally forgot the positive and negative up here. Some of you probably called me out for that. Please do not forget that. X is equal to the positive and negative version of I, which is, again, is just equal to, I'm going to write a note down here. I is equal to the square root of -1. That x is equal to the positive and negative version of I times the square root of 154 over 9. So you'll notice the negative is no longer in there because it was the square root of 1, and we took that out to become an I. Just a personal side note, I don't always draw my I's like backward J's. If you look at this word up here inside, they're both pretty straight. For imaginary numbers, I always give it a little tail. You certainly do not have to. I know it looks like a backwards J. That's not my intention. Anyway, so this is our final answer. I'm not going to have us simplify it any farther. If you'd like to write it out separately and have x is equal to I times the square root of 154 over 9, or negative I times the square root of 54 over 9, you can certainly write this as well. So this is practicing using the square root. Just know that if you see a negative inside a square root, take out the negative, turn it into an I, or an imaginary number. Hopefully that wasn't too bad. Let's get into our last 3 problems of dealing with a quadratic formula, since it's probably been a little while since we've done that. So let's see. First thing I want to remind you is when we're dealing with the problem, we've got ax squared plus bx plus c is equal to 0. Again, just like with factoring, you can only use the quadratic formula when everything is set equal to 0. And we'll solve for x, or whatever variable we have, with the quadratic formula, which I will rewrite for us right now. There we go. Okay, so let's get started on problem 13. Problem 13 is 3x squared plus 8x is equal to 80. So this is the case, again, it's not set equal to 0. We got to make it be set equal to 0. So we'll have 3x squared plus 8x. We'll subtract 80 on both sides. And now we can use our quadratic formula. Set up our a, our b, and our c. And plug this in by saying, let's see, x is equal to negative my b value of 8 plus or minus the square root of my b value of 8 squared minus 4 times my a value of 3 times my c value of negative 80. Make sure you bring that negative along. Divided by 2 times my a value of 3. So from here, I'm going to simplify where I can. So we'll have x is equal to negative 8 plus or minus the square root of 64. That comes from the 8 squared. Now we have a negative 4 times 3 times negative 80. I grabbed my calculator, but we end up with a positive 960 over 2 times 3, or 6. So when I add the two numbers underneath the square root, I get negative 8 plus or minus the square root of 1,024 over 6. Now this is a really big number. Unless it comes out to a nice number, I'm just going to have you leave it there. But it just so happens that the square root of 1,024 is actually a nice number. So we're going to get x is equal to negative 8 plus or minus 32, which is the square root of 1,024 over 6. If you're not sure if it turns into a nice number, just grab a calculator. But from here, we have the positive version and the negative version of this answer. So let's go through and try to find both of those versions. So I'm going to kind of do 2 little branches here. First, we're going to have x is equal to negative 8 plus 32 over 6. And our second version is going to be x is equal to negative 8 minus 32 over 6. So I'm setting out those plus and minus into 2 separate answers. I'm going to work on the plus side first. So let's see, negative 8 plus 32 It's going to give me 24 over 6. So we get x is equal to 4. That's our first answer here. Secondly, let's see, we'll have negative 8 minus 32, which is equal to negative 40 over 6. This is something we can simplify. If we divided 2 out of the top and bottom, we get x is equal to negative 20 over 3. And there we have our two answers. You may have noticed from the first few problems and when we've been factoring, but we're always going to get two answers, usually a positive and a negative. Now that's problem 13. This is a little more involved than they usually are, but I just want to show you sometimes you do get nice numbers and how to deal with that. Let's move on to problem 14. Move this up just a bit. So let's see, problem 14 is 6v squared is equal to negative 2v minus 5. You can subtract 6v squared on both sides to get it to be equal to 0. I, however, always like my a value to be positive just out of teacher habit. So I'm going to add 2v to both sides. So I have 6v plus 2v. I'm also going to add 5 to both sides. So I'm kind of just changing those signs. But now we're going to have our a, our b, and our c, and I'll rewrite real quick. B squared minus 4ac over 2a. Just rewriting that really quick so we have that in front of us. So let's see, we're going to have v is equal to negative our b value plus or minus the square root of b value squared minus 4 times our a value times our c value over 2 times our a value. So after I've plugged everything in, I start simplifying, so we'll have v is equal to negative 2 plus or minus, let's see, 2 squared, which is 4. Then we'll have a negative 4 times 6 times 5, and that's going to give us negative 120 over 12. So once we simplify under the radical, we'll get v is equal to negative 2 plus or minus the square root of negative 116 over 12. So 116, that's not a nice number. That doesn't have I'm going to restate it. It's not a perfect square. I'm not going to edit that. We're just going to leave it in. It's not a perfect square. So we don't have to actually find it, but we do have to deal with this negative. And just a reminder, what we're going to do is we're going to say, where is this? If we have a negative inside our radical, it's going to become, it's going to become an I, or an imaginary number, outside of this. And that's because I is equal to the square root of negative 1. So we can think of that negative as just multiplying by that negative 1. So we're going to rewrite our final answer as v is equal to negative 2 plus or minus I times the square root of positive 116 over 12. And there's our answer. But if you'd rather see it as two answers, which you totally can, you can have v is equal to negative 2 plus I times the square root of 116 over 12, comma, or and, negative 2 plus or minus, not plus or minus, just the minus, I square root of 116 over 12. So I will accept either of these answers. Let's try just one more. Let's take a look at problem number 15. So for problem 15, I'll write out problem 15 and then rewrite the quadratic formula real quick. Let's see, problem 15 is 10b squared minus b is equal to 15. Quadratic formula, actually, you know what? I'll sing it for you now. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Did you like my singing? That tune is to Pop Goes the Weasel. There's a very cute 20-second video on YouTube that has a weasel dancing around. I love it. Anyway, getting back to the problem, we want to start our problems by having this set equal to 0. So I'm going to subtract 15 on both sides. So we have 10b squared minus b minus 15 is equal to 0. So we have our a value our B value and our C value. In this case, our A value is our B value is a -1. So when we plug all of this into the quadratic equation, we'll have B is equal to negative our B value, which is already negative, so make sure you have those parentheses there, plus or minus our B value squared minus 4 times our A value of 10 times our B value of a -15, bring that negative along, divided by 2 times our A value of 10. So when we go through and simplify, we'll have B is equal to a -1, which is a +1, plus or minus the square root of -1 squared. So something paused, hopefully didn't last too long. So that's 1, and then we'll have a -4 times 10 times -15. Once you plug that into your calculator, you're going to get a +600. That's all going to be divided by 20. So once I add 1 and 600 together, I get B is equal to 1 plus or minus the square root of 601 divided by 20. And that's as simplified as we can go. Sometimes you get to here that 601 can't turn into a nice number. It's not a perfect square. There's no negative in front, so we don't have to deal with I. So this, I did not leave myself enough space. This is it. You can also write it out separately as B is equal to 1 plus square root of 601 over 20 and 1 minus square root of 601 over 20 if you want. But that's that. So there's a lot of kind of algebra practice here. I'm hoping you've experienced this all before. Hopefully not too bad once we get going at it. So let me know if you have any questions, and I look forward to seeing you during class.